my name is Kelly, and today I'm going to go over the 2009 Calc BC FRQ number 6 on Taylor series. Number 6 says the Maclaurin series for e to the x is e to the x equals 1 plus x squared over 2 plus x cubed over 6 continued, and the general term is x to the nth power over n factorial. The continuous function f is defined by f of x equals e to the power of x minus 1 squared minus 1 over x minus 1 squared for x does not equal 1, and f of 1 equals 1. The function f has derivatives of all orders at x equals 1. Part A says to write the first four non-zero terms and the general term of the Taylor series for e to the power of x minus 1 squared about x equals 1. This problem requires you to pay attention to structure. They tell you that e to the x is x to the nth power over n factorial, so all you have to do to find the Taylor series for e to the x minus 1 squared is to plug in x minus 1 squared for x. To find the general term of the Taylor series, you also have to look at structure. So if you look at the exponents, they're even numbers, 2, 4, 6, and then continued. So then you know that the numerator is x minus 1 over 2n. And if you look at the denominator for the first term is 1, the denominator for the second term is also 1, and then it's 2 and 6, so that's just the factorials. So the denominator would be n factorial. Part B tells you to use the Taylor series found in Part A to write the first four non-zero terms and the general term of the Taylor series for f about x equals 1. And they tell you what f is. It's e to the x minus 1 squared minus 1 over x minus 1 squared. This is the information that you already know. Because you know what e to the x minus 1 squared is, you can substitute it in by plugging in the first four non-zero terms into f of x. Then you would simplify by canceling out the 1's and also simplifying the x minus 1 squares. To find the general term, you have to again look at structure. So you notice that the top is the same as the top for e to the x minus 1 squared, and the bottom has been shifted 1. So the general term would be x minus 1 to the 2nth power over n plus 1 factorial. Oh, and don't forget, because it's asking for the first non-zero terms, you have to go another term after. But after you find out what the general term is, it's pretty easy to find out what the fourth term is. Part C says use the ratio test to find the interval of convergence for the Taylor series found in Part B. So just to review, the ratio test says if the limit of n approaching infinity of absolute value a sub n plus 1 over a sub n equals L and L is less than 1, then the series a to the n is absolutely convergent and therefore convergent. If L is greater than 1, then the series is divergent. However, if it's equal to 1, then the ratio test is inconclusive, and in other words, that means that no conclusion can be made about the convergence or divergence of the series. So to do Part C, all you have to do is to find the limit of a sub n plus 1 over a sub n. So after you have the basic form written out, you just have to simplify and cancel out a lot of things. So you know that n plus 2 factorial is the same thing as n plus 2 times n plus 1 factorial, and then the n plus 1's would cancel out. And then at the same time, x minus 1 to n plus 2 is the same thing as x minus 1 to the 2nth power times x minus 1 squared. So you can cancel out the x minus 1 to the 2nth powers. So after you're done canceling out everything, you have the limit as n is approaching infinity of the absolute value of x minus 1 squared over n plus 2. So here I separated the x minus 1 squared and the n plus 2 because you're finding the limit as n is approaching infinity, so you can just isolate the x minus 1 squared. After plugging in infinity for n, you get that this 1 over n plus 2 is the same thing as 0. So the whole thing would be x minus 1 squared times 0, which is 0. You know that 0 is less than 1, so that means this whole thing is convergent. But part C is asking for the interval of convergence. So by looking at the result of 0, you know that the Taylor series is convergent for all numbers, so therefore the interval is negative infinity to infinity. Part D says, use the Taylor series for f about x equals 1 to determine whether the graph of f has any points of inflection. A graph of f of x has point of inflection when the second derivative of f of x equals 0, or basically when the concavity changes. To do this problem, you would take the second derivative of f of x to see when the concavity changes to find the x value. So first you would have to take the first derivative. So to take the first derivative, you would find the derivative of the first 4 non-zero terms of the Taylor series in part B. So the Taylor series in part B was this. So you would take the derivative of those. Then to find the second derivative, you would take the derivative of these terms. Now you would have to find the general term. So again, you look at structure. If you look at the numerator, 3 is 1 less than 4, and 5 is 1 less than 6, and the exponents are again even numbers, so 0, and then 2, 4, 6, 8, continued. And then because you know that this is the first term, this is the second term, and the third term, you could use these n values to find a general term that would give these numerators. So to get 4 here, 2 times 2 is 4, and then 2 times 3 is 6, so that works, so 2n. And then 3 is 1 less than 4, 5 is 1 less than 6. So then you would multiply by 2n minus 1. And then you need to include the x minus 1 squared and x minus 1 fourth in the other terms. And this is even numbers, so it'd be x minus 1 to the power of 2n minus 2. Now you can look at the denominator. If you look at the numerators, they're the factorial of n plus 1. So like n plus 1 here would be 3, and 3 factorial is 3 times 2 times 1, which is 6. For here, n plus 1 equals 4, 4 times 3 times 2 times 1 equals 24. So the denominator would be n plus 1 factorial. After you get your general term, you can plug in the n values to test to see if you got it right or not. So if you look at the general term that we just found, because f double prime of x will always be positive no matter what value of x is used, f has no points of inflection. So here are some things to remember. I feel like with this problem, the most important thing is structure, because with structure, you can figure out the general terms of all their Taylor and Maclaurin series. And the second thing to remember is that when doing the ratio test, if the limit as n is approaching infinity of absolute value a sub n plus 1 over a sub n equals 0, that means that there's no radius of convergence in the sense that the series is convergent for all values, and so therefore the interval of convergence is negative infinity to infinity. I hope that this video was helpful, and thanks for watching.